Welcome to another class on motion graph. In today's class, we're going to solve questions on this concept, velocity time graph. Okay, let's start with the first question. A car runs at a constant speed of 15 meters per second for 300 seconds and then accelerates uniformly to a speed of 25 meters per second over a period of 20 seconds. This speed is maintained for 300 seconds before the car is brought to rest with uniform deceleration in 30 seconds. Draw a velocity time graph to represent the journey described above. And from the graph, find the acceleration while the velocity changes from 15 meters per second to 25 meters per second, the total distance traveled in the time described, and the average speed over the time described. Well, what an interesting question. Okay, let's start by drawing our graph. Okay, we have our graph here. Now, please, I want to pay attention, okay, because this question is technical. Now, a car runs at a constant speed of 15 meters per second for 300 seconds. Since we are dealing with velocity time graph, we're going to have velocity in meter per second and time in seconds. We're going to have time here, time in seconds. Okay. Now, the car runs at a constant speed of 15 meters per second for 300 seconds. So here I'm going to have, let's say this is 0, 0, you understand? So now let's say this is 15, you understand? This is the velocity at 15 meters per second. So we have something here, we have 15 here, and it runs at a constant speed. That means that the speed is not changing. And I told you in our previous class that when a car or an object is moving at a constant speed, the graph look like this, you understand? Please pay attention. In our previous class, we learned this. When a body is moving with a constant velocity of speed, this is how the graph will look like. So now we are told in the question that the car runs at a constant speed of 15 meters per second for 300 seconds. So now here I'm going to have a distance look like this. Don't mind the diagram, okay? I want to sketch out the diagram now. Now here will be 300. The distance from this point to this point will be 300, okay? 300 seconds. Do you understand? Okay, now let us proceed. And then accelerate uniformly to a speed of 25 meters per second over a period of 20 seconds. Now, having undergo a constant speed of 15 meters per second for 300 seconds, the car now accelerates uniformly to a speed of 25 meters per second. Now, from this point, it accelerates. And I told you in our previous class that when a car accelerates, the graph look like this, you understand? Accelerate. Okay, so it accelerates for 20 seconds. So I'm going to have here 20 seconds. So from here, so now the distance from this point to this point is what? 20 seconds. Now, if I want to calculate the distance from this point to this point, that will be what? 300 plus what? 20. You understand? That will be what? 320. Do you understand? Okay, now let us trace this to this point. This will be 25 meters per second. Okay, 25 meters per second. Okay, now let us proceed. This speed is maintained for 300 seconds. Wow, what an interesting question. After it accelerates to this point, the speed is now maintained for 300 seconds. So, and that means that the speed is constant for 300 seconds. And at constant speed of velocity, the graph look like what? This. Okay. At constant speed of velocity, the graph look like this. The speed is not changing. So for this, I'm going to have here. So now the distance between this point and this point is what? 300. Okay. That is 300 seconds. You understand? So the distance between this point to this point, that will be what? 300 plus 320 plus 300, that will be what? 620. Do you understand? Okay, now let's proceed with the question. Now The speed is maintained for 300 seconds before the car is brought to rest with uniform deceleration in 30 seconds. So from this point, the car decelerates to from this point the car decelerates at 20 seconds. So let's just call it is it 20? Oh, 30 seconds, sorry. The car is brought to rest with uniform deceleration in 30 seconds. So from this point to this point, it is 30 seconds. So now, from this point to this point, 30 seconds. Now, the total distance, the total time taken will be what? 620 plus 20. 620, which is distance from this point to this point, plus 30. You understand? That will be what? 650. So I'm going to have 650. So the total time taken is what? 650. Okay? Now, pay attention. Pay attention, okay? I want you to pay attention. This is the velocity time graph that you are asked to draw. Okay, that's the first question. If you look at that, you are asked to draw a velocity time graph to represent the journey. So you have a mark for that. Now, the acceleration, why the velocity changes from 15 meters per second to 25 meters per second. Okay, meter per second. The acceleration, when the velocity changes from 15 meters per second to 25 meters per second. Now, please pay attention. This is the acceleration that we are asked to determine. We are asked to determine the acceleration from this point to this point. So let us represent this point as A. Let us represent this as B, C, D, E, F, G, H. You understand? Now, to determine the acceleration when the velocity of the car changes from 15 meter to 25 meter per second, we just have to make use of the formula of slope. You understand? Don't forget, in our previous class I told you that when you are asked to calculate acceleration, you are going to make use of the slope. Okay? Slope is associated with acceleration. In velocity time graph, acceleration is associated with slope. Okay? So let me sketch this. The acceleration is equals to, please pay attention. To get the acceleration at that velocity, we just have to make use of change in velocity or over change in time at that particular moment. That is also the same thing as slope. You understand? So I'm going to have change in V over change in T. So now that will be V2 minus V1. You understand? V2 is what? That is the final velocity. V2 minus V1 all over T2 minus T1. Okay? Now, V2 minus V1. V2 is 25. So I'm going to have 25 minus V1. V1 now is what? 15. You understand? V1 now is 15. 15 meters per second. 25 minus 15 all over T2 minus T1. Now, the time taken at that moment, the first time taken is what? 0. That will be 0. And the second time will be 20. You understand? That will be what? T2, 20 minus T1. That is what? 0. So I'm going to have 25 minus 15. That is 10. 10 all over 20. That will be what? 0.5. So that will be 0.5 meter per second squared. That is the acceleration when the velocity of the car changes from 15 meters per second to 25 meters per second. Do you understand? Question 2. We are asked to determine the total distance traveled in the time described. See, don't forget, in the previous class I told you that when we are asked to calculate the distance in the velocity time graph, we just have to take the area of the graph that we have. You understand? The area of the velocity time graph gives the total distance. Okay? Now, but in this velocity time graph, we have many shapes. You understand? We have triangle, trapezium. Oh wait, no, this is not triangle. Sorry, rectangle, trapezium, and this rectangle and also a triangle. So we have to pay. You have to pay attention here. To calculate the area, okay, the total distance. Pay attention, okay? Total distance is equals to the area, okay? Now, the area of the velocity time graph. Now, let's start with, please, I want to pay attention. We're going to start with this, with the rectangle first, okay? We're going to start with the rectangle. That means we're going to have area of ABHO Okay, ABHO plus we have another area in that place. That will be what? B area BC. That's the shape BCGH. You see, I'm just trying to take the area of all the shapes. You understand? That is what I'm doing. Okay, I want to calculate the area of all the shapes. Now, the first area here is what? Area of this rectangle, the rectangle ABHO. You understand? And the second area is the area of this trapezium. That is what? Area BCGH. That is BCGH. BCGH. Then we add it to another area of this rectangle. That is area CDFG. You understand? CDFG. This area CDFG. Area of this shape particularly. CDFG plus the area of DEF. DEF. Do you understand? Now we're going to calculate the area one by one. Now we're going to start with the rectangle ABHO. ABHO. The total distance from this point to this point is what? 300. Okay. And the total distance from this point to this point is what? 15. Okay. So area of, please pay attention, area of ABHO will be equals to area of the rectangle is what? Length times breadth. You understand? So I'm going to have 300 multiplied by breadth. The breadth is 15. That will be what? Length times breadth. Let me put it in this place. Okay? Please just pay attention. Okay? All I need now is your attention. Area of ABHO, that will be length times breadth. That will be 300 multiplied by 15. Okay? Plus area of BCGH. Area of BCGH. That is the area of trapezium. You understand? You know, this shape, how will I draw it? Please, I want to pay attention. We have this shape. I mean, this is a trapezium, you understand? And from this point to this point is what? That is 15, okay? 15. And from this point to this point is what? 25, you understand? That is 25. Do you understand? And from this point to this point, which represents the distance from this point to this point, it is what? 20. You can see that that is a trapezium, you understand? From this point to this point is 20. From this point to this point is the same height as this. That's 15. And from this point to this point is what? 25. You understand? So that is a trapezium. So area of trapezium is what? Half the addition of the parallel side multiplied by the height. You understand? Area of a rectangle. Area of a rectangle. For a rectangle is what? Length times breadth. Area of a trapezium. That is what? Half into bracket A plus B multiplied by height. You understand? So A and B are the parallel side. You understand? And the parallel side here is what? 15 and 25. So I'm going to have 1 over 2, 25 plus 15 multiplied by height. The height here now will be what? 20. Please, do you understand what I'm doing? If you don't understand, listen to the explanation again. It's simple, okay? So now I have CDFG. CDFG. Now, what is this shape? This shape is also a rectangle, you understand? And the total distance from here to this point is what? 25. Please pay attention, okay? It's very simple, you understand? What I'm doing is that I'm calculating the area of the figure that I have in the graph, you understand? I have rectangle, trapezium, rectangle, and triangle, you understand? So I'm calculating the area of what I have in the graph. Since area, total distance is equal to the area, you understand? So total distance is equal to the area OA, B, C, D, E, F, G. You understand? Area of the shape is equal to the total distance. So I'm calculating the area one by one. The area of the rectangle is this. The area of trapezium is this. Now I want to determine the area of CDFG. That will be what? Length times breadth also, because this shape is what? CDFG is a what? Is a rectangle. You understand? So for this I'm going to have plus area of this, that will be length times breadth, that will be 300, which is the distance from this point to this point. Look, let me draw it here, okay? We have something like this. You can see that this is the rectangle. Now, the distance from this point to this point is 300, okay? And the distance from this point to this point is what? 25. So, for this, I'm going to have 300 multiplied by 25. Do you understand? Plus, now, we have to calculate the area of DEF. Don't forget that the shape of DEF is what? A triangle. You understand? Now, if you want to calculate the area of triangle, that will be what? Half base times height. Okay? Now, this is the base. And this is the height. The height is what? 25. So I'm going to have half base. The base is what? The base is 30. Half base multiplied by height. The height is what? 25. Multiplied by 25. Please, do you understand how I got all these values? If you do understand, kindly reverse the video and watch it again, okay? Now, we can calculate the total distance by adding all these values. 300 multiplied by 15, that will be 4,500. So for this, I'm going to have 4,500 plus 25 plus 15, that is what? 40. 40 divided by 2, that is 20. 20 times 20, that is 400. So I'm going to have 400 plus 300 multiplied by 25. That will give us 7,500, okay? 7,500 plus 30 times 25, that is 750. 750 divided by 2, that will give us 375, okay? 375. So if you add all this together, we're going to get the area. That will be 12,775 meter. 12,775 meter. That is the area. That is the area, which is total distance. You understand? The total distance here is this. Do you understand? Okay. Now, let's proceed to the next question. The next question says we should calculate the average speed over the time described. Don't forget that this is what? Distance all over time. You understand? And we have known the total distance as what? 12,775 meters. And the total time taken will be what? 650. So the speed is equals to the total distance, which is 12,775 meters, all over the total time taken. That is what? 650. So if you divide this by if you take the division, you're going to have 19.65. This will be 19.65 meter per second. Okay, that is the speed. Okay, so we've come to the end of the question. If you have any question regarding this particular question, you can drop it in the comment box, and if you want more explanation, you can let me know in the comment box. Okay, see you in the next class. To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.